To find vertical asymptotes of a rational function, our first step, we want to factor the numerator and denominator of the function and reduce it to lowest terms. The second step, we want to find the zeros of the denominator. If x, and we know that if x minus r is a factor of the denominator, then x equal to r would be one of the zeros, and that's actually the location of a vertical asymptote. The graph will never cross a vertical asymptote. It may cross a horizontal or oblique asymptote, but it will never cross a vertical asymptote because we know vertical asymptotes are locations of zeros of the denominator, which we know that the denominator of a fraction can never equal 0. So let's look at an example. If we have the function f of x equals 5x plus 5 over x squared minus x minus 2. So we know it's a rational function. We've got those variables in the denominator, rational fractional function. So first we need to factor. So if we factor the numerator, we take out the 5. We have 5 times x plus 1. We factor the denominator. We've got x minus 2 times x plus 1. So first we have to reduce this function to lowest terms. So remember, we see a common factor of x plus 1 in the numerator and denominator. We must first reduce it. So 5 over x minus 2. Once it's reduced, now we can say that any zeros of our denominator will be the location of vertical asymptotes. So we know the 0 of this denominator would be 2, because if I set x minus 2 to 0, I'd get an x value of 2, and that would cause this function to be undefined, which on the graph causes a vertical asymptote. So our vertical asymptote, our VA, is x equals 2. Now you'll notice we initially, before we reduced to lowest terms, we had a factor of x plus 1 in the denominator. And we'll talk about that shortly, but that's actually the location of a hole in the graph. So it is also an undefined region of the graph, but instead of being a boundary line, it's actually a hole that's punched out of it. And we'll talk about that shortly. So for now, though, our vertical asymptote is x equals 2. And if you just want to note that that x equal to negative 1 is a hole, and we'll talk about that shortly. And if you want to make a little note in here just about the lowest terms, this is our function in lowest terms after we reduce that common factor.